Theorem 20 states this: the diagonals of a parallelogram bisect each other. So pretty basic. We have a parallelogram where the opposite sides are parallel, and now we are introducing these diagonals, stating that if this is a parallelogram, the diagonals bisect each other. So we should get that this will equal that, and this side of the diagonal will equal the other side of itself. So that's what we're stating. So we're given a parallelogram ABCD with diagonal AC and BD intersecting at point O. We again are trying to prove AO is equal to CO and BO is equal to DO. All right. Already stated the given. Number 2. We're going to say that AB is parallel to DC and that AD is parallel to BC. Opposite sides of a parallelogram are parallel. That's the definition of parallelograms. So definition of parallelograms. Number 3, AB equals DC. Already stated, well, we didn't state this yet, but I hope by now a lot of these steps are like duh kind of steps. We've stated so many times already that opposite sides of parallelograms are also equal. Not only are they parallel, opposite sides of parallelograms are also equal. All right, so that is what we're going to state for our reason number 3. Opposite sides of parallelogram are equal. We could also state, since we've learned this corollary now, we could also state that parallel lines included in between parallel lines are equal. Same idea, just different wording. And so either one of those would work. Number 4. I'm going to say that angle 1, I'm going to label these in just a second. Angle 1 equals angle 4. I'm just going to label this angle 1 and this angle 4. I'm going to label this angle 2, label this angle 3. Angle 1 equals angle 4, and angle 2 equals angle 3. So now we're looking at these two parallel lines, and we have a transversal coming this way. Here, this parallel line is being cut by this transversal and forming this angle. Here, this parallel line is being cut by that same transversal and forming this angle. These are alternate interior angles. And since we've already stated that these are parallel, alternate interior angles of parallel lines are equal. So number 4, alternate interior angles of parallel lines are equal. Number 5, we can now state that triangle ABO is congruent to triangle CDO by angle, side, angle. Let's look at what we stated. We've stated that AB is equal to DC. We've stated that angle 3 is equal to angle 2, and angle 1 is equal to angle 4. And so you can see angle, side, angle, respectively, to this triangle here. So both of these triangles are congruent. And then we can state our, make the statement of what we're trying to prove. We can now say that AO equals CO, BO equals DO. All 4 of these lines here are a part of the two triangles we just proved to be congruent. This is the corresponding side of this triangle to this side of this triangle. So since they're corresponding parts, they are going to be equal to each other. AO equals CO because of CPCTE. Corresponding parts of congruent triangles are equal. And the same thing is true here. These are corresponding parts of both of these triangles, and they're both equal to each other. So this equals that, and this line equals this line. And so we now see the diagonals of a parallelogram bisect each other. We should even probably say that BD bisects, and I might even just truncate it even more. BD and AC bisect each other. And we can say that because the definition of segment bisectors, they cut a line into two equal parts. And we just proved that they are cut into two equal parts. And so we can say definition of segment bisectors. And there it is, Theorem 20.